Okay, let's unpack this. Today, we're diving into the cockpit's oldest instrument, the magnetic compass. It's your ultimate independent backup, right? Yet for many of us, especially prepping for that basic instrument rating, well, it feels like it has a mind of its own.
Yeah,
It's got these sort of sneaky errors. So our mission today is to decode those errors, figure out why they happen, and help make you a more informed and, crucially, a safer pilot.
What's fascinating here is just how vital that simple magnetic compass still is for, say, a GA pilot.
Right.
Particularly flying IFR and maybe a Cessna or something similar, when your fancy glass cockpit goes dark or maybe other systems fail unexpectedly.
That little compass is still there.
It's still there, and understanding its quirks isn't just about ticking boxes for the BIR exam. It's really crucial for real-world safety. You need to become a truly reliable pilot.
Yeah.
You've got to know what that compass is really telling you.
Absolutely. And to make sense of these, well, sometimes baffling behaviors, there's that great memory aid, VD-MOA.
Ah, VD Monet, classic.
So let's go beyond just, memorizing letters.
Yeah.
What does this VD-MOA actually stand for? And maybe more importantly, what does it really mean for us up there when we're flying?
Great question. Let's break down each letter. We'll connect it right to the practical side for a GA pilot and give some tips for your BIR too. First up, V, that's for variation.
Okay.
This is simply the difference between true north, what your charts are based on, and magnetic north, which is where your compass needle actually points.
So they're not the same. We can't just draw a line on the chart and fly that heading on the compass directly.
Exactly. What this means in the cockpit is your charts are true, your compass is magnetic. Always, always account for that variation when you're planning your flight path, converting between the two.
Got it.
Now, if the Earth's field causes issues, what about the metal and electrics in our own plane?
Ah, okay. That sounds like D for deviation, right?
You got it.
Ah.
Deviation is magnetic interference from the aircraft itself. Think about the avionics, metal bits, engine, even headset wires. They all create tiny magnetic fields that can nudge the compass needle off.
So how do we deal with that?
Well, how to remember this for the test in the skies. This is why you've got that little compass correction card, usually stuck right near the compass itself.
Ah, yeah.
Always check it before takeoff. It tells you the correction needed for different headings. And remember, it can change if you install new gear or have heavy electrical loads on.
Okay, makes sense. V and D, variation, deviation. What's next?
Next is M for magnetic dip. And this one's, well, it's really interesting because it's kind of the root cause of the next three errors we'll talk about.
Root cause. How so?
You see, the Earth's magnetic field lines aren't flat. They actually dip down towards the poles. Imagine the compass needle trying to stay level.
Okay.
But these magnetic lines are pulling one end downwards towards the ground. This downward pull is what really messes with the compass, giving us a stable horizontal heading when we're moving, especially turning or changing speed.
Ah, so it's not just a standalone error. It's the underlying reason the compass gets really tricky during maneuvers. Sort of the diva of compass errors.
You could say that. And it leads us straight to O for oscillation. This is just the erratic swings of the compass needle you see sometimes.
Yeah, turbulence mainly.
Turbulence, rough air, even just slightly unstable flight. What this means in the cockpit: don't chase a wildly swinging needle. It's giving you a general direction, sure, but it's not precise then. Just try to average the swings mentally. It's a guide, not a perfect instrument in rough conditions.
Okay, average the swings, don't chase it.
Got it. So that leaves the errors caused directly by that dip when we maneuver N and A.
Exactly. N is for Northerly Turning Error, the classic one.
Right.
When you're turning through northerly headings, the compass will either lag behind your actual heading or lead ahead of it.
Okay, how do we remember which way it goes?
Think UNOS, undershoot north, overshoot south.
UNOS, undershoot north, overshoot south. Right. So, turning to a northerly heading, roll out a bit early, undershoot your target heading. Turning to the southerly heading, fly past it slightly, overshoot. It's really crucial for rolling out accurately on instruments, all because that magnetic dip is tilting the compass card during the turn.
Okay, UNOS. That's a good one. And the last one, A.
A is for acceleration deceleration error. This one kicks in during speed changes, but primarily on east or west headings.
East or west.
Well, think of it like hanging dice in a car.
Yeah.
You accelerate forward, they swing back. The compass needle reacts similarly to inertia and that magnetic dip. So accelerate on an east heading, the compass briefly shows a turn north, decelerate, it shows a turn south.
And the opposite on a west heading.
Exactly. So the mnemonic here is ANDS, accelerate north, decelerate south. Remember that applies on east-west headings.
ANDS, accelerate north, decelerate south. On east-west. Wow, okay, that's a lot to keep track of.
It is. And examiners expect you to understand these concepts for sure. But what really matters is being able to anticipate and account for them instinctively in real flight, integrating it into your scan.
So putting it all together.
Yeah.
What does this all mean for us pilots, really?
Yeah.
Beyond just passing the BIR exam.
It means understanding VD-M&A isn't just theory, it's a fundamental skill. For BIR candidates, absolutely. But also for everyday IFR pilots. If we connect this to the bigger picture, look, despite all its quirks, despite that dip making it dance around, when you understand it, when you use it correctly, the magnetic compass is still the most reliable, totally independent backup instrument you have in a GA aircraft. No power needed, no complex systems. It's just there. A simple, reliable guide.
That's actually quite reassuring, isn't it?
Yeah.
Incredible, really. So next time you're pre-flighting, maybe take an extra moment with your magnetic compass. Can you already anticipate its little VD-M&A dance even before you take off? Knowing its quirks, well, it might just make it your most trustworthy friend when everything else goes quiet.